I'm going to have a lot of slides, so very, very different type of presentation. We're going to talk about convergence, technology convergence, which is something we are experiencing, we've been experiencing since last year, organic type of convergence and between technologies and what it means really. And so I'm going to take this as the central theme of the narrative and the story that we're going to talk about. I'll give you a bit of background. We'll talk about enterprise distributed ledger technology context, what drives it, and then we will look at how those convergences are manifesting themselves through some use case and from real-life example. I belong to a company called cloudyboss. We run a platform called Next Plus, which is an enterprise digital ledger basically platform. And our vision is to empower the fortunate 8 billion. What we mean by that is that the world of work is changing, and we believe that the startup trend, which we are all experiencing across all countries, is far more than a trend and has to do with actually that whole new economic paradigm with entrepreneurship. And so our goal is to empower basically startups, SMEs, enterprise. Many of our clients are coming from the enterprise sector, especially startups. We also use that startup theme with startup acceleration program with smart cities, as well as digital transformation program for large enterprise. So let me put a bit of context to this. What is an EDLT? We are the next generation of management platform. After ERP in the 20th century, cloud ERP at the beginning of the millennium, EDLT is, for us, the next management platform. And it's all about managing not only organization, but also ecosystems of independent organization. And what we see happening with EDLT is really that convergence of many technology, AI, DLT, blockchain, IoT, and many other type of technologies. The way we look at this is also from an organizational model perspective. So we're shifting from vertical organization, which were dominant in the 19th and 20th century, to horizontal organization, basically since internet was introduced, to today, distributed type of ecosystems of independent organization. Necessity drives, innovation. And that's really what drives everything that we do. So there's two types of challenges that we see, human challenges, technology challenges. On the human front, we all know what's going on, the amount of long-term threats which are really impacting humanity are quite monumental. But strangely enough, the solution to that is quite simple. It started here, actually, in India. 10 years ago, this is where the concept of smart city emerged. And as I have experienced, India is actually quite innovating in that space and is really doing a lot of things in solving the core problem with smart city, which is urbanization failure. But there's tech challenge too, which is some of the two core technology which underpin those challenges, human challenges, are blockchain, of course, and also AI. So on the blockchain side, just a round of just to check who's familiar already with distributed ledger technology in the room, who's from a technology perspective well aware of how blockchain function. You raise your hand. Okay, 2 or 3. So I'm just going to go through this quickly. Okay, a bit of a crash course on blockchain. We often think that blockchain is a 10-year-old technology. It's not. Okay, blockchain is a 40-year-old in the making, right? It started with Merkle, back in the 80s, and then that whole area of Byzantine fault tolerance, and then it evolves decades by decades, with, of course, a huge focus on cryptocurrencies and tokenomics this decade. But enterprise DLT is really what's coming to the fore now. So a 40-year in the making type of technology. Often I'm hearing, blockchain is a technology which is looking for a use case. Well, that's not what we are experiencing. You know, our clients are coming to us with extremely precise use case. You've got here a bit of an overview on it. I'm not going to delve into that because I'm giving a presentation tomorrow just on this, okay? And we will look at use case example and real life examples. But you can see that there's virtually hundreds of them, okay? Fintech and cryptocurrency being only one use case, okay? Right there at the bottom. For those who are not familiar with blockchain technology, you know, the core concept underpinning a blockchain is actually that notion of hash tree, Merkle tree. What is that? Well, if you look at the diagram there on the left, it's really about looking at those data leaves, all those data components at the bottom, and then through an hashing technique, bubbling that up all the way to the root. You might say, so what? What are we doing with this? Well, the key benefits of using hash tree is that if, for example, I have a block of data with 16 components, I just need 4 hash to validate, check, actually, that data. And so this grows logarithmically. If I start having 1,500 transaction or block of data component, I just need 11 hash to basically check or validate that data. That's the core of what is into blockchain. Now, is this blockchain? No, it's not. Blockchain is actually an ever-growing Merkle tree, okay? Now, I'm not going to get too technical on this, but the reason I'm talking about that is to understand immediately where are the challenges and where are, what is the way to look at DLT on a long-term basis. So you've got some example there of what are the benefits and also the challenges that basically underpin that technology. AI. AI is the second main technology which underpin everything that is going on. And AI has a number of challenges. First of all, you would all be familiar with the Gartner way of looking at hype from a technology perspective. But in the case of AI, and I think this also applies to DLT, we're not just assisting to one curve, right? It's more of a seasonal type of approach. We had that succession of winters and summers, which has been going on for 60 years, right? AI started in the 50s, and there's been 4 consecutive type of winters, you know, with that particular technology. The last one occurring last year, okay? With the Facebook basically demise, I think we've entered into the next winter for AI, and we know already how we're going to get out of it, which is quantum AI. Now, when we talk about AI, there's many ways of looking at that. Actually, 3 ways. What we call narrow AI, what we call generalized AI, and strong AI. But as of today, we're still dealing with narrow artificial intelligence. And we can do quite a lot, you know, with this, everything which is listed there on the left. So what are the AI basics? Well, if you compare conventional computing to AI, as you can see, in conventional computing, you would marry up data and logic to obtain outputs. Well, in AI, you do something slightly different. You marry up data with actually outputs, training data set, to obtain inference model, graph model, so logic. And this is the typical life cycle of a development of a machine learning type of component, where you train your system to a point where you are satisfied with its accuracy, and then you put that in production. The reason why this is important is because it highlights immediately some of the problems and challenges with AI. Trust, risks, bias, etc., etc. Now, why is this important? Well, it's important because it provides a context to why those technology convergences are happening. So let's look at a first case study. convergence between digital distributed ledger technology and actually as a way of mitigating data bias. Fefe Lee there explained quite eloquently what data bias is, but if you want to verify by yourself where data biases are occurring right now, well, you know, it's as simple as going in Facebook and running that type of search, okay? If you try that search, woman's professional hairstyle, you will obtain in the image section that type of results. Nothing wrong with that until you slightly change the search and you put unprofessional woman's hairstyle. And as you can see there, we start having a bit of a bias issue, isn't it? Okay? Well, that's not just in Google search. That's happening kind of everywhere. Okay? And you know the stories there of the type of demise we had in the HR recruitment sector. This is an example of what's happening with the police department software in New York, you know, so we've got quite a lot of issues there. Okay, how do we fix that? My peer earlier actually talked about that a little bit, but the K and what we're seeing happening is a convergence between IoT, DLT, and artificial intelligence. Let me give you a case study, an example of this. The Australian eldercare industry, actually, which I've been working with for the past 10 years. This was the status of the industry when I started working with it 10 years ago. A very, very, even to this day, a very, very damaged industry, right? The industry will suffer over the next 5 years a loss of something like 80 to 85,000 staff because of the millennial cliff, the demographic type of change that we are all facing. So a lot of low morale, a lot of issues in the industry. We started a project 10 years ago, which was all about tackling that issue of higher demand, lower resource. And that was all about empowering carers to actually increase their time caring from an average of 55 to 60% to 75%. And the way we do that, which is quite a dramatic shift, was to actually transform the building, the hospitals, the facilities, the eye care facilities into carers. And that's what we did. Okay? We transformed a pilot type of project into a carer. How? Pervasive IoT. Replace all the data input with actually IoT device, wearable device, collect this. And so what happened there is by actually creating that big data influx through IoT, we had a necessity to start implementing DLT to ensure the security, the integrity of the data. What also happened is that another convergence occurred. With so much data, nurses were not able to run their assessment and care plan anymore manually. We had to shift to a machine learning type of approach to care plan analysis and incident avoidance. What also happened is that shift in the concept of information, okay, from a normal I/O type of approach and perspective on information to smart information, which routes itself to the right user at the right time in the right place. So a totally different approach on information. Again, DLT, necessary to eliminate any type of friction, especially between independent parties. So think about hospitals, ambulances, Department of Health, et cetera, et cetera. These are the outcomes. It's working. The industry is adopting that. We are getting a lot of international type of exposure and interest on this. So that's an ongoing type of process. So here's an example of how IoT, DLT, and AI are converging, not as a matter of commercial choice, but as a matter of technological necessity. Second case study, data cartelization. What do I mean by that? Tim Cook say it better than I could, right? If something is free, it means that you're not the customer. You are the product, okay? And the issue with that is, many actually. Data cartelization, privacy breaches, stolen identity, propaganda. We saw all the problem last year with Cambridge Analytica, which in my view have triggered the fourth winter for AI. We're also seeing that in the area of EMR, electronic medical records. Let me take an example on that, right? With EMR, with any type of AI approach to the data, the question is always, where do you conduct the AI? Do you approach that from a centralized model perspective, because you need all the data before to run your machine learning component, or do you do this at the edge, but you need the processing power to be able to do that, and that doesn't necessarily exist as of today? Well, there is a third way of doing this. Distributed model. Build an ecosystem, move away from cartelization, and yet leverage of the benefit of AI by collecting data from the ecosystem rather than a centralized place. This is what we're doing with EMR right now. Any type of centralized EMR project over the past 10 years has been a complete failure. Okay? In America, in Greece, in UK, those projects have been abandoned. In Australia right now, we went with an EMR, a centralized EMR type of system, and I think on the first day, an enormous amount of people opt out. Okay? Why? You get the list of problems listed here. Okay? EMR or centralized approach to AI actually doesn't work. So what's the solution? Well, we're working right now with a client in UK on a distributed ledger approach to EMR. And the solution is really all about put the user back at the center. Okay? Now, it is more complex, there's no doubt about that, but it works. And complexity is not complication. Complexity refers to another way of looking at those projects. Okay, economics. And I'm going to take that quote from Warren Buffett to understand what the problem is and where the ethical and the ethics of actually what we are doing in economics start creating some problems. So Warren is here referring to Wyco, his insurance company, which is, as you know, a main engine for his whole activities. And of course, what he's referring to is the fact that with smarter mobility, one of the consequences of smarter mobility is going to be road safety. And road safety is potentially a catastrophe for the insurance business. Okay? Here's an opposite view, Jack Ma, okay, which is, well, you can't compete. Okay? And what really Jack Ma is saying there is that, well, there's another perspective on that. And the perspective is an economic one, a macroeconomic one. We know that many jobs are going to be destroyed by automation. And we can look at that from the perspective of a loss. But there's another perspective on this. And the other perspective, and I know it might be difficult in India to think like this, because you've got many, many, many people. But that is not the case everywhere else. We are basically, as a population, total population, we're growing, but we're also aging. And that is causing what we call the millennial cliff, which is there's actually proportionally not enough workers to support the entire population. So I think that's the other way to look at automation, from a macroeconomic perspective. And it's happening. Shared economics, tokenomics, knowledge economics, they are all answers to those macroeconomic problems. It's not just about the macroeconomy, it's also about the micro, the nano-economics. We faced that recently with one of our own features. So we are building, as we speak, it's in training mode, it's going to go live pretty soon, an autopilot feature in our system, Next Plus. This is all about empowering entrepreneurs to actually go to the next level in terms of enterprise management or ecosystem management, by which, well, they should not even have to log to an app to check their situation. They should have a chief automated officer who take care of all that complexity for them. So we're building that, okay? We're changing completely the UI approach to applications. But the problem we faced is one of our core segments is startups, okay? And the problem with startup is they don't have data. And if they don't have data, well, you can't run any artificial intelligence if there's no data. So how did we work around that? Well, the solution, again, convergence. We immediately realized that the only way to build that AI feature was actually to converge it with a DLT approach to data. And so we created a database marketplace by which established enterprise share their data with startups. Now you've got the immediate problem of what is the value of data? Okay, that's a new problem. Hopefully we didn't have to do any work on that because MIT has already done the job for us. They did that mid-year last year. They came up with a valuation model for data that we can apply actually quite easily to any type of data marketplace. So this is a new branch of economics, which is really emerging as we speak. So here's, again, that idea of convergence between IoT, DLT, AI, both on a macro and nano-economic level. Now, we talked about quantum earlier. I think there was some question about quantum computing, right? And good questions. You know, for me, the discussion about quantum is not about DLT itself. It's about what's happening with internet, okay? And Robert Muller summarized that very, very well. As you can see, two types of companies, those which have been hacked, those that will be hacked. Okay? So what he's referring to here is the fact that internet as we know it is under threat, pervasive threat everywhere. Okay? Here's a list, you know. And one of that threat, two of those threats actually, the fact that TCP/IP to this day and moving forward is actually not Byzantine fault tolerant. So there's a problem there. And the other type of issue is that quantum computing coming forward is trivializing public key encryption. So shaking the fundamentals of blockchain as we know it. So how do we fix that? How do we go to the next internet? Quantum. Okay? The next internet will be quantum. It will not be actually an internet, it will be a multinet. When we talk about quantum, we need to look at three dimensions: hardware, network, and apps. In the hardware side, the race is on. Okay? Google, IBM, D-Wave, all fighting to build that chip which is going to go on that little mobile phone or that little device with quantum capability. Okay? It's happening as we speak. In the software side, the main issue that we are having right now with quantum is that everyone is thinking in terms of integration with the existing IT technology. Okay? We differ. We disagree. Why? The unfortunate bit in the word qubit is actually bit. Okay? Bit refers to binary logic, binary digit, zeros or ones. A qubit doesn't work like that. A qubit is described by a wave function. And so what we think is what needs really to happen with quantum computing is we need new post-Boolean type of mathematics. And this has already been done, actually. Where? Well, in AI. Okay? The biochemist with everything which has to do with classes of problems that we qualify as hard problems, such as protein folding, already use quantum computing that way. Okay? They don't think in binary terms. They think in terms of complex hard problems which can be solved only through quantum logic. We're also working on this, okay, but from a different angle. And one of the proof of concept that we want to use, a first proof of concept for that post-Boolean type of era which is coming for the IT industry, has to do with Hyperledger. So our issue there is not to solve quantum Hyperledger. Our issue is more, let's use Hyperledgers or DLT technology as a core topic to actually introduce post-Boolean mathematics and another way to thinking about information technology altogether. So I'm going to wrap up. And I'm going to wrap up with that quote, which I love, okay? They didn't know it was impossible, so they did it, all right? That's really what's happening in many, many areas right now. A couple of recommendations there, but I'm happy to discuss with you, any further during the breaks, and I'm going to just finish on that code there. The best way to do it is actually to do it. Thank you very much.
See, as a user, our experience with AI and blockchain have been mixed bag because both are evolving. Now, when you combine two or three experimental things, 2 or 3 evolving things, isn't it a recipe for a bigger disaster?
Sorry, come again with a question.
No, I was saying that all these are experimental, evolving technologies, be it the AI, be it the blockchain, so and perhaps even the IoT. So when you combine these 3 for an actual business use case, isn't it a recipe for a bigger disaster? Because all 3 are experimental. We have challenges with each of those individual projects. You combine them together, isn't it a bigger problem?
From an implementation perspective, and I understand that's going to be the topic that we're going to talk about earlier. Our experience right now is that you need to break down actually the cases, okay? Because you've got different category of organizations or ecosystems. Our experience right now is that, and the reason why we are focusing on startups, not sure if you remember at the beginning, I mentioned startups are the way we go. Why? Startups get it immediately. The startups we are working with, they're not trying to build organization, they're building ecosystems. And so for them, it's very concrete. And the type of ecosystems we're building are actually not experimental at all. We're really doing it. Where the difficulties with implementation are emerging are with conventional organizations, large corporate, large multinational. We see that. We see a lot of interest. We are approached every day by very, very large multinational who tell us, look, we're really interested in your system. We want to implement that. Where do we start? The key difficulty there, and this is where I guess all of the uncertainty in the corporate world is happening, is the fact that you've got a 20th century or 19th century type of corporate organizational model which does not necessarily work well with the distributed organizational type of model. And so that creates all of those frustration, if you want, or uncertainties on how do we implement that. Our response to this, because we needed to go back to enterprise, is really taking the startup acceleration angle and the dematerialization and digital transformation type of angle for large organizations. That's happening with corporate, it's happening with government, okay? And it's almost like circumventing the problem. For us, implementing DLT as pilots without challenging the organizational model is a bit problematic. It's a bit like trying to connect centralized node and putting that DLT type of glue in between it, right? Might work, but is it ideal? Not necessarily, because you introduce actually more vulnerability points, so there's a security problem. Where when you build your business model from day one around that idea of distributed organization, you don't have that issue. So us as an organization, we deliberately focus on startups and SMEs. Corporate are important to us, but they come third. And we as much as we can, we'd like to take the angle of digital transformation as opposed to come in and implement a pilot. Does this make sense?
No, maybe I didn't communicate correctly. I was not talking about implementing DLT in a large corporate and trying to change a small corner. No. Even if DLT is a separate business altogether and where it works, it has its own challenges in implementing it, getting the ROI. And the same is the case with AI and IoT. So I'm talking about even in a startup case, even in a case where you're not burdened by the baggage of the old and all that stuff.
Okay.
Each of these technologies bring their own challenges in actually getting the results. So you combine all of this, even in a standalone mode. So that's why I was asking.
Okay. Well, I guess the core discussion I was going, or the core theme that I was going to, that I've explained, and I might not have explained it well enough, and so I apologize for that, is that what we are experiencing right now is that convergence is not happening as a matter of commercial choice or project choice, it's happening organically. Can I give you a quick example of that? One of our clients in the supply chain, in the maritime, actually, supply chain, started approaching us because they wanted to implement a DLT ecosystem for incident registration and maintenance service provenance certification. The problem, if I may, is if you are a boat owner located in Amsterdam and you got a job to go to Argentina and one of your parts on your engine break down in Argentina, you don't necessarily know anything about the maintenance service guys who are going to fix your boat in Buenos Aires. So you need an ecosystem by which you can verify that. So this is how it started. Organically, really as a natural organic type of evolution, we're now talking about predictive maintenance, which is, well, what about the boat doesn't leave Amsterdam because an AI who has all the data now on all the supply chain for the part engines and is not going to be able to predict, hey, look, your trip is going to be 12 days, but in 6 days and 4 hours, that part, serial number 123, is going to break down. You need to fix that before you leave. So here's an example of what I mean by organic convergence. You don't have to materialize it or seek it. It's just happening. It's happening naturally. You might say, where is the IoT dimension there? All those boats are running IoT software to actually monitor all of those parts. Okay? So here's one example of organic convergence as opposed to commercial convergence. Thank you.